Good morning, sir. Thank you for giving this opportunity to introduce myself. This is Vijay Babu. Coming to my education qualifications, I have done my BE from Usman University, Hyderabad. I have done my MTech from JNTU, Hyderabad. Right now, I am pursuing my PhD degree from JNTU, Kakinada. Coming to my teaching experience, I have 10 years of teaching experience in premier reputed institutions like Gudlaval Engineering College, Gudlavalleru, Vardhaman College of Engineering, Hyderabad. I am very passionate about my teaching, and this enthusiasm towards teaching has made me to teach in GATE institutes like GATE Forum, GATE Academy, and IS GATE Academy in Hyderabad, Chennai, and Orissa, and other parts of the country. I have mentored more than 10,000 students in GATE examination as well as RRBJE and state government jobs. Coming to my merits, I have qualified GATE 3 times. Recently in 2022 GATE, I have achieved a rank of 4700. Even I have qualified UGC NET 2 times in the years 2013 and 14. Coming to my awards, I have two NPTEL awards. One is in signal systems and the other is communications. That is, one is gold and other is the silver. So this is my a little introduction. Now I would like to go with a demo lecture on one of the important concept in communication, that is the analog modulation technique. So that is the double sideband suppressed carrier. So that is the DSBSC. So now let us consider the modulation technique as the double sideband suppressed carrier. So this is the modulation technique what I want to introduce now. So for any modulation technique, you must require a message signal as well as the carrier. So this is very important. Okay. So now see here, I am considering a message signal M of t. M of t, this is the message signal, and I have to take the carrier. In analog modulation technique, most of the times you take the high sinusoidal, high frequency sinusoidal as the carrier. So let us consider this is the high frequency sinusoidal as the carrier, that I am considering it as the AC cos 2 pi FCT. So this is the high frequency sinusoidal carrier. However, who will generate this? So this will be generated by some oscillator. Let us consider this is the oscillator which is generating the high frequency sinusoidal carrier. And to generate the DSBSC, you require a simple multiplier. So this is the multiplier which is going to generate the DSBSC. For this multiplier, I am giving the message signal M of t as the input and the carrier as the AC cos 2 pi FCT. And the output directly you will be having the S of t DSBSC. S of t DSBSC. Now see here, S of t DSBSC, I would like to first of all write the expression of the S of t DSBSC. How the equation of this look like? Simply this is the multiplier, right? So for any multiplier, if you are giving two inputs, what is the multiplier output? Always a simple multiplication of the message and the carrier. Okay. So now the output S of t DSBSC is given as what? M of t into AC cos 2 pi FCT. So this is M of t multiplied with AC cos 2 pi FCT, which is equal to, you can take AC is a constant, right? So you can take it out this. So very simple, AC M of t cos 2 pi FCT. So this is S of t DSBSC. So this is the time domain expression for the DSBSC signal. Okay, so this is the time domain expression for the what? A DSBSC signal. But you cannot understand anything with this time domain expression. If you want to understand anything about a signal, compulsory you must convert this into what you call frequency domain. When you try to convert a signal into frequency domain, then you'll be getting some frequency information, right? So for that purpose, what I try to do, I try to apply Fourier transform for this. Why Fourier transform? Already we well known that if you try to apply a Fourier transform on any signal, you will be getting the frequency information. So for this DSBSC also, I would like to apply a Fourier transform here. It is very clear. So for this, if I try to apply the Fourier transform, see here, so this I am applying Fourier transform, then the equation will be in terms of f. Here the equation is in terms of t's. will be converted into equation in terms of f's, that is S of f DSBSC. Okay, so S of s DSBSC, the expression is given as AC. Okay, so m of t into cos 2 pi fct. This is the modulation property in Fourier transform. So if you try to apply modulation property in Fourier transform, this will be m of f minus fc plus m of f plus fc divided by 2. Okay, so this is S of f is equal to what? AC by 2 m of f minus fc plus m of f plus fc divided by 2. So this is the frequency domain representation of what you call DSB. Yes. Now I will try to plot it. How to plot this? To plot this is m of f minus fc means what? This m of f spectrum you are shifting by an amount of fc. This is delayed and this is the advanced. So you are shifting the spectrum of m of f by an amount of fc, right side as well as the left side. So to draw this plot, first of all you should know what is m of f. Is it not? If you know m of f, then you can easily shift this left or right and you can plot the DSBSC. So how you will be having this m of f? You don't know. I have just started with an arbitrary signal m of t. So now to plot this, first of all I have to assume what is the spectrum of m of f. So what I try to do, I try to assume the spectrum of m of f is something like this. The maximum frequency component is Fm. So this is the spectrum of m of f. Okay, so the spectrum is extending from 0 to Fm frequencies. And at 0 you are having the higher magnitude or higher strength, and as the frequency is increasing to Fm, the strength has been reduced, and beyond Fm the strength has becoming 0. That means the bandwidth of this message is given as simply Fm. Units are hertz. Okay, so this is that means this m of f is band limited to Fm. So this is the thing what I want to convey. Okay, right. So once you know the spectrum, now see here I have taken it as a triangle. You can ask me a question, why it is always a triangle? Why not you take a rectangle, something like this? Or why can't you take a parabola shape? Or why can't you take any arbitrary shape, something different? Yes, dear students, you can take any shape. If I try to start with this shape, I have to explain the DSBSC spectrum in this shape only. If I take a rectangle, I have to explain the spectrum in that shape. Okay, this is just my assumption. What I'm saying, this is just my assumption. That's it. Why? Because to go ahead in plotting S of f DSBSC. That is my idea. Now, as I have assumed this m of f, I am ready to plot this S of f DSBSC, and I'll try to calculate the bandwidth of this DSBSC signal. Okay, now see here. How will you plot it? However, frequency is on x-axis. It's very clear. Okay, and so this is mod S of f DSBSC. Clearly see here, the first term is what? M of f minus fc. M of f minus fc means it is spectrum of m of f which is centered at fc, because f equal to fc. So means it is the right shift of m of f by an amount of fc. Let us consider this is the fc point. So you have to make this m of f a right shift by an amount of fc means here it is centered at 0, automatically this will be centered at what? Fc. So the same picture you have to redraw exactly like this. If you try to redraw like this, the 0 has been shifted to Fc means this Fm will be shifted to what? Higher frequency, Fc plus Fm. It's very clear. Okay, similarly the lower frequency is what? Minus Fm. So minus Fm will be Fc minus Fm. That is the idea in plotting this m of f minus fc. Once you are very clear with this m of f minus fc, you can easily plot m of f plus fc. What is this? This is simply the left shift. That is simply the spectrum of m of f at exactly f equal to minus fc. So minus fc is what? This is minus fc. What you have to plot? Spectrum of m of f. How will you plot it? Spectrum of m of f. That's it. And what will be the higher point? So this length is ff, means minus fc plus fm. Some positive than minus fc. What is this point? More negative. More negative means both are minus. More negative than fc. Both are minus. And the height of this, if you try to assume the height here is 1, okay, the height will become what? Simply AC by 2. So this becomes AC by 2. The height is simply AC by 2 and m of 0. So this is the height. So this is the DSBSC spectrum what you are getting at the output of this modulator. Once you know the DSB spectrum, you can calculate the bandwidth. For any signal to calculate the bandwidth, you have to consider only positive frequencies. It is very clear. Okay, and in the positive frequencies, you have to consider the higher frequency component and the lower frequency component. Now see here, what is the higher frequency component? Fc plus Fm. What is the lower frequency component? Fc minus Fm. And now coming to bandwidth is always Fh minus Fl, that is Fc plus Fm minus Fc minus Fm. So which is equal to 2 Fm hertz. So this is the bandwidth of the what you call DSBSC signal. This is the bandwidth of the DSBSC signal. So this is the basic concept behind the DSBSC concepts, and you can detect this. You can detect this using the synchronous detection. And the advantage of this with the amplitude modulation concept is very simple. Here the carrier is suppressed. There is no carrier at Fc. In amplitude modulation, what you will be having? In amplitude modulation, you will be having a carrier also. But here you are having only upper side band and the lower side band. So you are having only upper side band which is extending from Fc to Fc plus Fm, and lower side band which is extending from Fc minus Fm to Fc. So there is no carrier here. So the carrier is suppressed. As the carrier is suppressed, that is why you are calling this as what? Double sideband suppressed carrier. And very, very important, as you are suppressing the carrier, you can say that the lot amount of power is saved. And the advantage of this DSBSC system is simply the efficiency of this DSP system is given as simply 100%. In amplitude modulation concept, you are wasting lot amount of power, but in DSBSC it is not like that. So the power is not wasted. So that is why I am calling the efficiency is almost exactly equal to how much this is? 100%. And practically this is used in the point-to-point communication. Point-to-point communication means, let us consider you have a PCB board. There some modulation technique is required to transmit your signals. There point-to-point communication generally go for this DSBSC because a lot amount of power is being saved when compared with the amplitude modulation technique. Okay, so this is the basic background of this DSBSC concept, and you can detect this using the synchronous detector. So this is the basic demo video which I would like to give. So thank you for giving this opportunity. Thank you so much.